All right, Foundations Pre-Cal 10 short video to tie down what a linear equation actually is. Remember, linear means straight lines, so we're dealing with equations of straight lines. We will look briefly at nonlinear equations in this class, but we explore them more in higher grades. So, difference between linear versus nonlinear is that a linear equation is a straight line, which means it has what's called a consistent slope. And we learned this one in grade 9. This is y equals mx plus b. It is slope-intercept form, which means any number that represents the b is your y-intercept. What does that mean? That means you are where you go through the y-axis. So that means this number here, plus 5, goes through my y-axis right there at plus 5. The m is your slope. And your slope is rise over run, change in height over change in length. So in this case, we have a number -2. Well, as a fraction, that's -2 over 1, which means for every 2 we go down, because it's negative, we go 1 in a positive direction, which means we look like this. Down 2 over 1, down 2 over 1, down 2 over 1. We essentially create a staircase, and at each step is your next point, and then we just connect the dots. There is my straight line that represents the equation -2x plus 5. Again, here I have my y-intercept of -2. So I know that this point exists on my graph. Now in this case, my slope is 4 over 7. So rise of 4, run of 7, both positive. So you can consider that you go up 1, 2, 3, 4, positive direction in the y, and then over 7. Now, important to consider that 4 over 7 is equal to -4 over -7. So that means you can, in fact, go down 4 and the negative x direction 7, and you'll still end up with a consistent graph. That's the whole point. There it is. Looks good. And remember that the graph is the graph. You want to erase the staircase if you've drawn it in to finish up, because it shows that you have a good idea of your line. The staircase just shows how that line gets created. So that's slope-intercept form. It's the dream come true because it literally tells us key pieces of information about that graph. Standard form, ax plus by equals c, is a little bit more frustrating with that because it doesn't tell us a y-intercept or a slope, but it does give us some good information. Consider the fact that no matter where you cut through the x-axis, right, your x-intercept, what's your y value along here? All of them, the y value is 0. So what that means is we can solve for our y-intercept by setting x equal to, our y equal to 0, we can solve for our x-intercept. And we already know from our y-intercept that our x value is 0. So this is a great place to start. So this becomes a plug and play. So when y is 0, it means this is 0. So we have 4x equals 8. We can solve for x. Divide both sides by 4, we get x equals 2. So that gives us a point, a coordinate 2, 0. When x is 0, we have, in this case, 4x is 4 times 0, which is 0. So we just have y equals 8. So it tells us as well, another point, 0, 8. Now think about the symmetry of your graph. This is telling me for every 2 I go over. So I would say take that number and change the sign. Take this number, change the sign, or move 2 more away from it. So to 4 or to -4. It just aids in the simplicity of finding another point. Because what we're doing now is we're plugging in full values and solving. So if x equals -2, we have 4 times -2 plus y equals 8, which means we have -8 plus y equals 8. And if we add 8 to both sides, we get y equals 16. Now this is all well and good, but this is going to be off our graph. So let's try x equals to 4 and see what happens. So everything stays the same, but what happens is we change what we're plugging in for x. So this time we're plugging in a 4. So now we get 16 plus y equals 8. Subtract 16 from both sides, and we get y equals -8. So here we have a whole bunch of different points, and we can graph them. We have 2, 0. We have 0, 8. And now if we went to -2, you can see we're trending way off the graph. So if we go over to 4, we go down to -8. And there is your graph. So you can get the intercepts, which is awesome, and then you can get a third point, any third point, just to make sure you did it right the first time. So let's try that again. Now here, this equation looks a little bit more confusing, but remember that to get rid of multiple fractions, we can multiply the entire equation by the lowest common denominator. So in this case, between 2 and 4, the lowest common denominator is 8. So we end up doing this. What this does is it gives us this equation. 8 divided by 4 is 2, 2 times 3 is 6x, 8 divided by 2 is 4, 4 times 1 is 4, so 4y equals 24. This is the exact same equation, it's just easier to deal with. So now consider when x is 0, the 6x is gone, we have 4y equals 24. So when x is 0, y is -6 because we divide by a -4 on both sides. So there we get 1 point. Now what about when y is 0? Well, when y is 0, we have 6x equals 24. Divide on both sides by 6 this time, we get x equals 4. So now what point do I use next? Well, how about x is -4? Or you could go x is 8. You could pick points in between, but let's go with -4. You can pick any point you want. So this means 6 times -4 minus 4 times y is equal to 24. So -24 minus 4y equals 24. Add 24 to both sides. -4y equals 48. So in this case, y equals -12. So again, this is going to put us off the grid. So let's see what happens if we go to +8. Now, being off the grid is not the end of the world. It just means we can't visualize it as nicely. So if we change the x value from -4 to +8, how does this change our equation? Well, we have 6 times 8, which means we have 48. Subtract 48 from both sides, and we get -4y equals -24, which gives us y equals 6. Divide by -4 on both sides. So now you can see we can plot these points in something that makes sense. 0, -6, 4, 0, and then 8, 1, 2, 3, 8, up to 6. And there's our graph. And you can see that as we go towards -4, we're going off the grid. We're going to go down to that -12. So again, it's about simplifying the equation and then plotting to make life easier. Now we have two special cases, vertical lines and horizontal lines. And these are actually pretty great because this is your equation. X equals 3. Well, where does that exist? That exists right here. Where else does that exist? I don't know, here, 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 here. All of these points, no matter what their y value is, all have an x value of 3, which means any x equals line is a vertical line. And I know that that can be counterintuitive because the horizontal axis is the x-axis, but vertical lines are x equals lines. Similar vein, if you have a y equals, you have y equals 3. Where does y equal 3? Anywhere along this line. So that means a y equals line, anything y equals is a horizontal line. Those are the special cases for linear equations. So this ties to section 2.2. Look at the 2.2 video for a full one, but this is a quick short. All right, keep up the good work. We're working our way through at a good pace.